So now we are up to testing for symmetry. And remember, there's only two types of symmetry that we actually test for. That is even symmetry and odd symmetry. But you wouldn't know which one you're testing for at the moment. You need to actually do the first step, which is evaluate the function, the original function, not the reduced version, by filling in a negative x for all the x's that show up across the entire problem. So I'm setting up the numerator, and I'm also setting up the denominator. When you actually do this problem, you're going to simplify the expression in the numerator. When you square a negative, it's positive, so it's 2x squared. When you multiply two negatives, it is positive, and then you have a positive 24 at the end. In the denominator, squaring a negative, it is positive, and then my negative 4. At this point, when it is simplified, you want to compare this to the problem that's in this box. They are not exactly the same because this is a minus and this is a plus. Therefore, you have to state that the f of negative x is not equal to the original f of x. And that would imply that there is no even symmetry. If the boxes were exactly the same, there would be even symmetry. If the boxes were exactly the same and there was an extra negative in front of the box, then there would be odd symmetry, but there isn't. So therefore, f of negative x is not equal to the negative f of x, and that implies that there is no odd symmetry. Now at this point, you are done with all your work. You have to actually sketch the graph. So in order to sketch the graph, you want to draw your x-axis and you want to draw your y-axis. And then you want to go through all the information that you figured out and put it on the graph. So there is definitely a hole in the graph at the point 2 across and down 2. So 2 across and down 2, there is a hole in the graph. That takes care of the first one. There's an x-intercept at 6 across, 0. So I'm labeling that. Second one is done. There's a y-intercept at 0, -6. So I'm labeling that one and checking it off. There is a vertical asymptote at x equals -2. So I'm marking it off and I'm putting in the vertical asymptote. I usually use a different color for the vertical asymptote because it really isn't part of the graph. It's just a boundary line. Horizontal asymptote is y equals 2. So once again, another boundary line, and labeling that one y equals 2. All right. You are not going to intersect that horizontal dotted line. There is no symmetry, so I guess I'm ready to go. Now, I had told you that the testing locations are surrounding vertical asymptotes and zeros. So since there's only one vertical asymptote and only one zero, you're checking a point in this window, which is the window from -infinity to -2. You're checking a point in this window, which is -2 to 6. And you're checking a point in this window, which is 6 to infinity. And you may select any number you want in those intervals. So in the first one, I think I'm going to pick -3. And I'm going to go to the reduced version, this one, and I'm going to fill in a -3. Well, the top is 2 times a -9, which is negative. And the bottom is a -3 plus 2, which is a negative. And a negative divided by a negative is a positive. But when you get a positive, it means you are above the x-axis in this location. So you have to fit into the dotted lines, but it's got to be above the x-axis. When you pick a number between a negative and a positive, always go for 0. It's the easiest one to test. When you fill in a 0, it is 2 times -6, which is negative. And when you fill in a 0, that is a positive. But a negative divided by a positive is a negative, and that means you're below the x-axis. So I'm below the x-axis. I guess I have to pick up this, maybe pick up this. Now you could do a wave. You can kind of make it look like a steeper arch. I don't care how you do it. It's perfectly fine with me. I'm sure it doesn't have a little wave. I'm sure it comes from very low, goes through this point, then goes to the hole, skips over the hole, and goes here. So I'm sure it actually looks more like the second one that I'm drawing. But if you drew the first one, I could not mark you wrong because you don't have any extra information to see how it bends. But I'm going to guess it looks like that. And as you go down, it's actually following and staying to the right of that vertical asymptote. Once you get there, after the number 6, I'm going to pick the number 10 to check. If you fill in a 10, it's a positive times a positive. And if you fill in a 10, the bottom's a positive. And therefore, when you divide two positives, you get a positive, which just means you're above the x-axis. And it gradually creeps higher and higher, but it never gets higher than the horizontal asymptote, and it can't intersect it. That's the picture of the graph. But you need to do the domain and the range to have this completed. So when you are looking at your graph, the domain, there's a set rule for it. Your job is to always skip the vertical asymptotes and the x coordinate of the holes. So you're skipping over -2 and you're skipping over +2. So it's -infinity to -2, skip over -2 and go to 2, skip over 2 and go to infinity. That is the domain. So you always skip over the x coordinate of the hole and the vertical asymptote. The range is not as easy. When you are doing the range, you have to look at the picture. You have to look to see if you have any onto sections, which you don't. Something that goes from bottom to top without any gaps. Then you got to look for y coordinates of holes and the possibility of a horizontal asymptote. So y coordinates of holes and the possibility of a horizontal asymptote. Because it does not intersect the horizontal asymptote, you will jump over it. And you will jump over the y coordinate of the hole. So your range, you're jumping over a -2 and a +2. So it's -infinity to -2, union, -2 to 2, union, 2 to infinity. And that's how you write down the range of the function.